Yes, this is Professor Groves again. Uh, I'm going to finish up the video on the Module 5 assignment. I thought we would go back and just refresh your memory about what we did last class. And so we have this scenario. And from that scenario, there are some key points that we want to discuss in our conclusion. We have a specific sales rep who claims that his home sales are $275 per square foot. Are his homes significantly larger than those in the Pacific region? So we want to do our t-test. And based on that result, do we recommend that he uses the new ad? Now, I just wanted to bring back the graphs that we looked about our sample data. And you can see from this sample data that our sales rep, right here, he's at 275, and he's better than all of these. His sales are better than all of the listing prices that are in the Pacific region on this side. But is it statistically significant? So let's go through and finish up our test of hypothesis. So we found that we had our test of hypothesis. We got our t of negative 1.99. And just as a refresher, we had our h naught. Mu is equal to 275, and HA, the alternative hypothesis, is mu is less than $275. So we want to know, is our rep better than the Pacific region? And mu is the true average for the Pacific region. Okay, so given that information, we always want to draw our normal curve. I'll make this a little bit bigger. And so our normal curve, and you're asked to reference the normal curve in your calculation section. Okay, the claim is that it was $275. And remember, we have a p-value. And so now we have to calculate this p-value. And we had a sample mean here of $236 compared to our sales rep, which resulted in a t statistic. We did all the calculations, and we got t is equal to negative 1.99. So now we want to find this p-value. And it's a probability. The p-value is a probability. And so we want to find the probability that our t statistic is less than negative 1.99. And there's videos that I have posted that shows you how to do it in Excel. But sometimes the internet is really nice, and I found this website called stattrek.com, and in this website, okay, it's asking pull down. So we have a t-score, and because we have a t-score, we have degrees of freedom. So we need to state the degrees of freedom. And the degrees of freedom is n minus 1. So for my example, my sample size was 50 minus 1. So my degrees of freedom is 49. Just a hint, your degrees of freedom, since your sample size is 1,001, your degrees of freedom will be 1,000. So I can put in here the degrees of freedom is 49, and my t-score was negative 1.99. Right? And so it populates it down here. We're finding the probability that t is less than or equal to negative 1.99. And we're using less than in this example because it's a left-tailed test. And it will calculate the p-value. Okay. So using that tool, I got a p-value of 0.0261. So you should write this probability statement, and that number is based on your t-value. And then your p-value over here is 0.0261. So you want to talk about, in this section, when it talks about the normal curve, that you have a t-statistic that's negative 1.99 and a p-value of 0.021. And you can exceed the expectation if you start talking about this right here. To be fancy is mu naught. Okay, it's that number right there, 275, and we're comparing it to our sample statistic. So now we can make a decision. We have all the information to make a decision, okay? And it says related to the significance level, and we've already stated that our significance level is 0.05. Now think of this, okay? Small p means we are going to reject H naught, and big P, this p-value, P, is we fail to reject. And in doing this, there is a standard methodology on how we want to write this statement. Okay? And we want to make connections between the p-value, alpha, do we reject or fail to reject, and do we have convincing or we don't have convincing evidence. Okay? So we have our p-value. So since our p-value, which you should state it, 261, okay, and our alpha here is equal to 0.05. Since our p-value is less than alpha 0.05, we now have convincing evidence. We can reject the null hypothesis, a small p-value, and actually 0.261 is a big p-value, so that would give us a different decision. Right? So this should be 0.0 0.261. Right? Since our p-value is less than alpha 0.05, we reject the null hypothesis and we can make a conclusion and have convincing evidence. Okay, and when we're making this, we're talking about we have convincing evidence that the average square foot for the Pacific region is less than $275 per square foot. Okay, so the key points are we got to compare the p-value to the alpha. Small p-value, we reject the null hypothesis. If this had been a big p-value, bigger than 0.05, we would fail to reject the null hypothesis, and we would not have convincing evidence. So that's what you want to include here under the calculations. And then in the conclusion, going back to what we talked about, is that you want to write one paragraph. Okay? And your paragraph should be easy to follow for this sales rep who's not a statistician. Right? Talking about are your conclusions statistically significant? And in this case, it is statistically significant at alpha 0.05. And so, what should the agent do? Should the agent use the ad? Okay. So, just to help you with this, I can't give you the answer, but just to help you understand this, the question was, is the agent better than the Pacific region? And if the agent is better than the Pacific region, then he should decide whether he should get the ad or not get the ad. All right. So I hope that helps you, and I'm looking forward to your assignments, and please send me an email with your feedback on the video, and let me know how you found it and if you found it helpful. Have a good evening.